හැමෝටම සුබ දවසක් වේවා. Today I'm going to explain practical chemistry, electrochemistry part. So I will try to do some other things also in practical chemistry, but due to time constraint situations, we won't do much things. However, I will cover as much as I can. So this is electrochemistry of practical chemistry. Okay, in electrochemistry of practical chemistry, we build up electrochemical cell. So metal rod of one particular metal rod, like P metal rod, we dip that rod in its iron containing solution, electrolyte Pn plus, and another rod, shall we name that as Q rod, we dip in Qn plus electrolyte solution. These both are known as electrodes. So we have to connect them to build up an electrochemical cell. We have to connect these two electrodes. So I will introduce a salt bridge. It will connect both electrodes. Okay. It's containing potassium chloride, saturated potassium chloride, strong electrolytes. Okay, so they will maintain the electrochemical cells connection in between these both electrodes. So we are doing experiment in chemistry lab to measure the voltage or EMF, electromotive force of this electrochemical cell by using potentiometer. In potentiometer, we have a wire. Its length may be 200, maybe 100, maybe 400, doesn't matter. Okay, this is our potentiometer wire, and its circuit according to the our book. This contains a battery which has known voltage, usually accumulator. So this is our working battery. We accurately know its EMF. Okay, according to diagram, this will connect to a galvanometer, and here there are two terminals. We can connect this our electrochemical cell for these two terminals, and this last terminal, which has a connection we know as jockey. Okay, we will keep it on this wire and we will measure the voltage. How can we measure the voltage? So important thing here, you have to know the positive terminal of working battery should connect to the positive terminal of this electrochemical cell. Positive terminal of this working battery, here the positive terminal comes here and this here, and it will comes down here, and this should be the positive terminal of this test cell, and the negative terminal of this working battery should connect to the negative terminal. Diagram should be like this. So to do this experiment, we have to carefully observe this on this electrochemical cell, and we have to identify the positive terminal and negative terminal. How can we identify the terminals? That's the important thing next. Okay, how can we identify? So there are two types of things we have to know. If we know one thing, we can easily observe, or easily we can identify the positive terminal and negative terminal. So in electrochemical cells, anode should be the negative terminal, and the thing happening there is oxidation. In electrochemical cells, its cathode always is the positive terminal, and the process is reduction. These are constants always. In electrochemical cells, anode should be negative terminal, and the process is oxidation, and cathode should be the positive terminal, and process is reduction. So we know how can we identify this anode or negative terminal? How can we identify this positive terminal? We have to get an accurate or good knowledge about the electrochemical series. Lithium, potassium, barium, calcium, sodium, aluminium, manganese, zinc, chromium, iron, cadmium, cobalt, nickel, tin, lead, after that hydrogen, copper, mercury, silver, bromine, platinum, chlorine, iron, or gold, Raptaram. What is the Sinhala poem? Lithium we have to remember always. First one is lithium. Potta Berunu Kahatu Soma Maggie Alisa Manchi Tundena. We know අපි දන්නා තුත්තනාගම් කියලා කියනවා සිංක් වලට. ඉතින් ඒ හින්දා තමයි මේ තුන්දෙනා කියලා කිව්වේ. මැන්චි තුන්දෙනා, කරට, ක්‍රෝමියම්, යකඩෙන්, කැඩුණු කොට්ටෙන්, නිකටට ගසාලා කියන්නේ one word, නිකල්, tin, SN mean tin, ටිකකින්, lead, දී, හද්ද, hydrogen, කොළඹට වස්සවාලා. Okay, රසයේ රසදී, mercury, රිදී, බරටම bromine, පටවලා, කෙල්ලේ රත්තරන් කියලා තමයි මතක තියාගන්න. That's a Sinhala poem. Okay, however, this is the order of electrochemical series. Here, when we go from top to bottom, උඩ ඉඳලා පල්ලෙහාට යනකොට reduction potential increasing. පල්ලෙහාට යනකොට මොකද වෙන්නේ? ඔක්සිහරණ විභවය වැඩි වෙනවා. ඔක්සිහරණය වීමේ හැකියාව, ability to oxidize, ability to reduce, ability to be reduced will be increasing when we are going top to bottom of this series. So the things which we meet when we are going to downstream, those will be tend to reduction. Yala reduce වෙන්න බලනවා, and the top level things will be oxidized. So reduction potential is increasing downwards. Okay, so reduction potential is lower in top level things. So highest reduction potential contained here according to this goal. Okay, so that means the reduction potential, more negative terms will be we can find in top level, more negative, and positive things we can find in downstream. Okay. එතකොට ඔක්සිහරණ විභවය පල්ලෙහාට යද්දි වැඩි වෙනවා. ඒ කියන්නේ උඩ හරියේ තියෙන අයගේ ඔක්සිහරණ විභවය ඍණාගයක් පල්ලෙහාට යනකොට ධන බව වැඩි වෙනවා. Positiveness of this electrode potential or reduction potential will be increasing when we go from top to bottom. හරි නේද? එතකොට we have to remember this electrochemical series. On the other hand, in examination they will give two electrode potentials. The synonym for reduction potential is electrode potential. Electrode potential equal reduction potential, doesn't matter. Sometimes in examination, in questions, they will give the reduction potential of both metals by observing them. Sometimes they will give negative 0.23 and other one will be negative 0.28. What is the more negative one? More negative one is this. What is the more positive? When we compare these two values, 0.23 is near to 0. Yeah, බිඳුවට කිට්ටු වෙනවා. This 0.28 is somewhat this 0.23 is near to 0 and 0.28 somewhat away from the 0. We know that. So positiveness is higher in this 0.23. Positiveness will be higher. Here negativeness will be higher. Negativeness. So we know reduction potential increasing means it will be reduced. So this negativeness here is near to 0, that will be goes to positive side than 0.28. Yeah, බිඳුවට කිට්ටු වෙන මෙයාට වඩා එහෙනම් positiveness is increasing, that means this is going to reduce and this will be oxidized. Likewise we can identify positive charge and negative charge. So however we will do some exercises. I will discuss some past papers and easily you will find out that thing. So however you have to know what is the positive terminal and negative terminal here. Okay, so at negative terminal there should be oxidation. If shall imagine this P will be negative terminal and Q will be positive terminal. So connection should goes to this negative terminal, should connect to this side, should connect to this side, and this positive terminal should connect to this side, and this is the correct way. However, in examination sometimes they will mix up these two electrodes. So they will connect this positive terminal to negative terminal and negative terminal to positive terminal. They will mix up. Doesn't matter. However, if we connect correctly, the measured EMF will be positive. If we connect the system correctly, these electrodes according to the diagram, positive terminal to positive terminal and negative terminal to negative terminal. If we connect correctly, the EMF value will be positive. However, if we connect in wrong way, EMF value will be same, but the sign will be negative. What's the meaning of this positive and negative? If the EMF value is positive, that means that is spontaneous. That's why EMF ගන්නවා. If EMF is negative, that will be non-spontaneous. ස්වයං සිද්ධ නොවේ, අස්වාභාවික ක්‍රියාවලියක්. It will be not spontaneous if the EMF value is negative. If you got a negative sign That means you connected this battery wrong way. Your diagram is wrong. You have to rearrange the electrodes. Okay. Sometimes they will ask what is the spontaneous oxidation, spontaneous anode reaction, and you have to suggest spontaneous cathode reaction. Spontaneous means naturally anode will be oxidized and cathode will be reduced. However, if they mix up these two electrodes, according to the diagram you can observe, if the positive terminal of this working battery connected to a positive, we imagine that according to diagram this positive terminal should connect to the positive terminal, but sometimes they will give wrong diagrams. It seems we connected to positive terminal, however they mixed up two electrodes, so that won't be spontaneous. However, you have to identify whether it is spontaneous or not. That's the thing. Okay. ඔයාලට අඳුර ගන්න වෙන කියන්නේ සමහරට එක්සෑම් එකේදී මේ දෙක මාරු කරලා දෙන්න. ඒ කියන්නේ පොසිටිව් දැන් මෙයාගේ පොසිටිව් ටර්මිනල් එක තියෙන පැත්තට මේකේ පොසිටිව් ටර්මිනල් එක තමයි සම්බන්ධ කරන්න ඕනේ. හැබැයි නෙගටිව් ටර්මිනල් එක සම්බන්ධ කරලා දෙන්න පුළුවන්. එහෙම වෙලාවට ඒක ස්පොන්ටේනියස් වෙන්නේ නැහැ. සුවල් සිද්ධ නැහැ. ඍණාගයක් තමයි තියෙන්නේ EMF එක. ඉතින් එක්සෑම් එකේදී මේ ප්‍රශ්නේදීම අහන්න පුළුවන් what is the spontaneous anode කියලා. එතකොට ඔයාලා හරියටම identify කරගන්න ඕනේ what is the spontaneous anode. ස්වයං සිද්ධව naturally ඉන්න anode එක කවුද කියලා. Here P. According to that you have to write down the equations. However, if they ask according to the diagram එකට අනුව ලියන්න කිව්වොත් එහෙම ඒක වෙනම එකක්. එතකොට ඒකට අනුව ලියන්න ඕනේ. Spontaneous කියලා mention කරොත් spontaneous එක ලියන්න. Okay. I have to explain some theories also. We have another way to find out the EMF of electrochemical cell. We know the usual expression for this potentiometric experiment. There is a common expression. We have to know that here EMF of our cell is equal here total length of the wire, and here the distance of distance we measure. Distance we measure by using this jockey. Okay, so we have to multiply it by the known here. Consider its voltage as P. We will multiply by P. There is a nice equation in your book. Go through that rather than this. This is one type of calculation expression. However, instead of this, we can use another way. What is that? There is another way. You have to know that thing also. Okay, imagine this is A and B. Okay, so it contains resistance. We know that wire contains resistance. එයාට ප්‍රතිරෝධයක් තියෙනවා. Resistance of unit distance. ඒකක දිගකට තියෙන resistance එක unit distance resistance is R. In 1 unit the resistance is R. Okay, so here our unknown, that means our electrochemical cells, its voltage, its EMF will be, we give a sign as E test, E test cell, our test cell. And also we can provide another known cell also, except this one. This is already fixed battery. We use another known voltage containing battery. We will give a sign as EK, E known. Okay, we use these three things. Here potentiometry, that potentiometer and its battery and this setup, and we use our electrochemical cells. By using that, we are going to measure its EMF value. Its EMF value will be ET. We don't know. We will calculate. And we use another battery. We know its voltage. Known voltage containing another battery, EK. Okay. So unit distance, the resistance of unit distance is R. What is the method? At first we will connect our electrochemical cell to these two terminals. We connect our electrochemical cells and we will keep our jockey here. What happened here? When we keep this jockey at this here, this A, the galvanometer reading will be goes to one direction, and if we keep this jockey at this end, the galvanometer reading will be go in this way. That should be go two ways. If not, your diagram is wrong. It should go both sides when we keep this jockey at both sides. Okay. So when we are getting the distance when the galvanometer reading is 0. That means the voltage difference of this A and here C, voltage difference of this A and C points is equal to the voltage of our test cell. What is that? Here we know this is known voltage containing battery. However, here this wire contain it possesses a resistance. So along with this wire, because of this resistance, voltage will be different. Wire එක ප්‍රතිරෝධයක් තියෙනවනේ. මේ එකින් එක ලක්ෂයට යනකොට මොකද වෙන්නේ? එයාලගේ voltage එකේ තැන් තැන් වලදී වෙනස් වෙනවා. දැන් එයාගේ දිග අඩු වෙනකොට voltage එක වෙනස් වෙනවා. එතකොට අපි මේක තියෙද්දි යද්දි මොකද වෙන්නේ? galvanometer reading එක බිඳුවක් වෙනවා. ඇයි බිඳුවක් වෙන්නේ? මෙන්න මේ වයර් එකේ A සහ C ලක්ෂ දෙක අතර තියෙන විභවාන්තරය අපේ ටෙස්ට් සෙල් එකේ විභවාන්තරයට සමාන වෙනකොට තමයි දෙකේම මෙහෙට here its current will go here and this current will be go here and both will be cancelled out. That's why the reading is 0. Both opposite currents will be cancelled out. So that's the thing. So we will first connect our electrochemical cell and we will measure the length. Imagine the length of this electrochemical cell. Electrochemical cell, we will consider its resistance. Here imagine this distance is x. In electrochemical cell distance is x. We know the resistance of unit distance, it is R. So it will be resistance and this will be, we can get the we know expression for voltage E equal I R. When the galvanometer reading is 0, E equal, we don't know the amount of this I, okay, current. However, here R is the resistance of unit distance. So distance is x. Here IRx is the potential difference in between these two wires. Okay. So that value we got when we connect this electrochemical cell. Again, what will we do? We will connect. Initially I said we use test cell and another non-voltage containing cell. So now we will connect a cell battery which has a known voltage, and we connect it, and again we will read the reading. At that time sometimes its value will be here or here, doesn't matter. Another line B, we will consider that second time known cell. However, the galvanometer reading will be 0 at both currents are equal. We know this P cell always supply constant current. So same current I, EK, here ET, equal I, the resistance of unit distance is R, and that distance will be Y. We don't know Y of this our known cell. Previously we used test cell, our electrochemical cell. Now we can divide this both equations. I to I will be cancelled out, R to R will be cancelled out. We know X divided by Y. So ET divided by EK is equal here X divided by Y. So we can get expression for ET. We don't know this our test cell. ET is equal X divided by Y. Here our EK. We know EK or known voltage containing battery. Another battery other than this lead accumulator. X we can find out, Y we can be measured, and we can calculate ET. That's the second method. There are two ways to get EMF value of our electrochemical cell. So first one is I told you that initially we connect this one and we will divide the length of the distance we get from the jockey and divide by total length, and we will multiply by this P voltage. That's another way. If we have supplied this type of another known voltage containing battery, you can use this method also. Okay. Those are the things you have to know. Okay. And I have to explain some other important things also. However, we will discuss them by discussing this question. This is the paper here 2017 18 question paper. We will discuss that. I know you may have the paper. If not, please go to the description of this video, and I will add my Google Drive link to that past paper folder. Go through that. Okay. 2017 18 paper. Okay. Here at 50 Celsius temperature is 50. A student prepared a galvanic cell by placing wire of metal X in solution of its ions X2 plus. Ions are X2 plus. Okay, and placing a wire of metal Y in solution of its ion Y3 plus. Okay, and then bridging the electric contact between these two solutions using salt bridge. We used salt bridge. Okay, he measured its EMF using a potentiometer as shown in the diagram. I will draw the diagram according to the paper. Here switch, negative terminal, positive terminal. Wire, here A, here C, here this is working battery. Working battery, and here galvanometer, here test cell or standard cell. Did you see that? The standard cell. In second method, I explained previously another second method to calculate the EMF of electrochemical cell. That is, in that situation we use the standard cell, another standard cell. Okay, and here our jockey. Here that point will be B. What is that? We will put our jockey. Okay, B. The length AB, when there was no current through the galvanometer. When there was no current through galvanometer, that means galvanometer readings will be 0. The distance of AB will be 81.0 plus or minus 0.1 centimeter. He observed that the metal wire Y is connected to the galvanometer. Metal wire Y, here Y connected to the galvanometer. They given that hint. So here Y, Y3 plus, here X, X2 plus. They given that data. He observed that the metal wire Y connected to the galvanometer. So this is the connection Y and this is X connected to the galvanometer. X to the variable resistance. X to the variable resistance. He could not find voltmeter to measure the potential difference across AC. So we have to measure the voltage of A and C. That means voltage of this working battery, we have to measure that by using a voltmeter. We should have a voltmeter. At that situation we can use that first equation. That means distance of AB divided by AC and multiply by this EP. So we can calculate E test cell. However, we have to know this EP. To measure EP, we should have a voltmeter. But here they mention we don't have a voltmeter. So what should we do? We have to get that alternative way. I explained secondly. What is that? He could not find a voltmeter to measure the potential difference across AC, across the terminals of working battery. During the experiment, however, he found standard cell. He found an standard cell. Standard cell. In the laboratory and repeated the potentiometer experiment by replacing the test cell. Now, second time, this is first time, and secondly, he will use standard cell. This is second time, and again he will do the experiment and he will get the distance of AB. He determined the length of AB. At that time, AB distance will be 53.6 plus or minus 0.1 centimeter. Okay. When there was no current to the galvanometer, on the standard cell, EMF of it was the voltage of this standard cell is given as 1.2 plus or minus 0.1 volt. Okay. Okay. Now, on the other hand, they have given an expression for error calculation. Very important thing. Here, delta y square over y is equal, here delta y over y whole square is equal delta a divided by a square plus delta b over b square plus delta c and c square. I will explain. Very easy equation. Okay. Now, in first question, they ask given reasons, identify the negative terminal metal X or Y of the cell prepared by a student. What is the negative terminal in which, from this X and Y? What will be that? So, if the student correctly connected this experimental setup, the negative terminal should be the negative terminal of this working battery. So, negative terminal of this, we can go through that wire which connected to negative terminal. It comes here and here and here and here and here. It is Y. So, Y is the negative terminal. What is the reason? In correct experimental setup, the negative terminal of our battery, our test cell should connect to the negative terminal of the working battery. That's the reason. That's the correct setup. Okay. So, next question. What is the spontaneous cell reaction? So, if the diagram, here we assume this student connected this diagram correctly. There is no any clue to get an opposite idea. They are asking, what is the spontaneous cell reaction? What is the meaning of spontaneous? Spontaneous means, according to this electrochemical series, the top level things of series should be oxidized and lower level things should be reduced. So, according to their locations, if we connect correctly the negative terminal to negative terminal, in other words, this negative terminal of this working battery to the anode or negative terminal of our test cell, it is known as spontaneous thing, because we connected them correct way. So reaction will happen correctly. That means spontaneous reaction will happen. That's the idea of spontaneous reaction. අපි හරියට මේවා කනෙක්ට් කරලා තියෙනවා නම් ඔක්සිකරණය වෙන කෙනානේ ඉතින් ඇනෝඩ් එක කියන්නේ. ඇනෝඩ් එකේ ඔක්සිකරණය වෙන්නේ ස්වභාවිකව. කැතෝඩ් එක වෙන්නේ ස්වභාවිකව ඔක්සිහරණය. මේ දෙක හරියටම වෙන විදිහට මේක කනෙක්ට් කරලා තියෙනවා නම් ධනාග්‍රයට ධනාග්‍රය ඍණාග්‍රයට ඍණාග්‍රය මේක කියනවා ස්වයං සිද්ධයි spontaneous කියලා. So this is spontaneous. So in here. What is spontaneous reaction? Before write down spontaneous reaction, we have to write down spontaneous anode reaction and spontaneous cathode reaction separately. So spontaneous anode should be here Y, and here we know in electrochemical cells anode will be negative terminal and oxidation. So anode here, anode is our Y. It will be Y will be turned into Y3 plus and 3 electrons. Okay. What about this cathode X? It will be cathode means it is positive terminal and reduction will be happen. So cathode reaction will be spontaneous cathode reaction. This is spontaneous anode reaction, and the spontaneous cathode reaction will be X2 plus will get 2 electrons and we convert into X, and it will, what will happen in this electrochemical cell? This Y rod will dissolve. Y rod will ionize and dissolve. With the time that rod will be dissolved. නේද? කාලෙත් එක්ක Y rod එක oxidize වෙවි ඒක දිය වෙලා යනවා ඒ තහඩුව. අපිට අලුත් තහඩුවක් දාන්න වෙයි කාලයක් යද්දී. What happened to X cell? This X rod, it is reduction, that means X2 plus ions in the solution will get coming electrons from this wire and it will deposit. එයා මේක deposit වෙනවා. ඒකනේ වෙන්නේ. So here solid, here aqueous, we have mentioned the physical state. Okay. To get the overall reaction, we have to get equalized number of electrons in both anode and cathode. සමාන electron ප්‍රමාණය. So here 3 electrons, here 2 electrons. Those are not equal, so we have to get both of them. We have to get to an agreement. Same electron amount. So we will multiply by 2 here, first one, and we will multiply by this by 3. So, and we will get the summation of this equation y solid, here 2, we multiply by 2, plus in this equation 3x3 plus a plus 3 into 2. You don't want to write down this number of electrons because they will cancel out in both sides. Equal here 2y3 plus a plus here 3x solid plus 6 electrons. So 6 to 6 will be cancelled out, and power of reaction will be 2y solid plus 3x a plus 2y 3 plus a plus 3x solid. This is the overall reaction, and they ask this spontaneous cell reaction. In next question, they asked denote the potential difference across A and C. A to C potential difference will be P. If they given in these two terminals A and B, for first and last terminals, potential is P. It is the hint to know the potential of this working battery. Actually, the potential of these two ends mean the potential difference of this potential of this battery. It is P. And the length of AC, length of this AC is L, second data, and EMF of the cell prepared by the student. Student prepared the cell, its EMF is E. We have to get the relationship between this L, P and E. How can we write down? In general, we know, in first case my explanation in experiment, we got this equation E, this potential of this or EMF of this our test cell E is equal to the length of this A and B, our measurement, divided by total length is L. Okay, and the voltage of working cell is P. So they didn't given AB as AB. They only given E, L and P. But A and B, this distance we know. How? In question they given that the length when the galvanometer reading is 0, when we connect this test cell, that was 81.0 I guess. 81.0 centimeters. Okay, we have write down this relationship only. Okay, that's the answer. And they ask, write down the relationship among EMF of the standard cell P and L. Another expression we have write down the relationship of standard cell potential. The standard cell potential, that means this second time. The standard cell potential they given as 1.2 volt. So its voltage, we know common expression, its voltage 1.2 is equal, the length they given as 53.6 centimeters, total length we know L, and the this is the voltage of working batteries P. Okay, calculate the E. We have to calculate this E value. So what we have to do? We have to divide this 1 and 2. We have to divide first equation by second. L will be cancelled out, P to P will cancel, and we will get E divided by 1.2 is equal 81 divided by 53. That's the answer. By calculating this, here 53.6 centimeter and centimeter both will be cancelled out, and E will be 81 divided by 53.6 into 1.2. So final answer will be 1.8 plus or minus 0.1 volt. You have to give this error also. Okay. At last, not last, the before one to last. Estimate the error. Oh, that's very important. They given this equation for error. For equation, when there is an equation y equal a divided by b into x. For this type of equation, we can use this error equation. So our equation is two distances divided, one distance will divide by another distance, and it should multiply by another value, potential value. These two are distance values, and this is potential value. So I will erase. So according to this equation, we will write down this error calculation equation. So this delta y and y, that's the error. This delta y is the error of our voltage or EMF reading of our test cell. That's the error of this final reading. We got that in previous calculation. The value is 1.8 plus or minus 0.1. However, we have to write down this plus or minus value is this calculating error. So error of this calculated EMF value, error of this calculated EMF value in previous when I'm writing down this value, I wrote down as 1.8 plus or minus 0.1. It is wrong because that value we calculated by using an equation. නේද අපි සමීකරණයකට දාලා නේ හොයාගත්තේ. එතකොට අපිට සමීකරණයට දාලා හොයාගත්ත එක්කෙනාගේ error එක plus or minus 0.1 කියලා දාන්න බෑ. Why it was 0.1? In this question they given the voltage of this test our working battery as 1.2 plus or minus 0.1. That means that value they calculated by using the voltmeter. එයාලා voltmeter එකක් පාවිච්චි කරලා දැනගෙන තියෙනවා. This 0.1 is the error of voltmeter. Error of voltmeter. However, this value we calculated by using an equation. අපි සමීකරණයකින් හොයාගත්තේ. Because of that we have to calculate the error by using an equation. අපි ඉන්ස්ට්‍රුමන්ට් එකකින් නම් තව එකක වැලියු එක හොයාගන්නේ. එයාගේ error එක තමයි මේ. හැබැයි අපි equation එකක් පාවිච්චි කළා නම් වැලියු එක ගත්තේ. එයාගේ error එක equation එකකින්මයි හොයන්නේ. නිකන් අපිට දාන්න බෑ හිතු මතේ. So here according to this equation we will modify this provided equation. Here delta y is the error. So delta E, this is our error according to our calculated value, and divided by E, our calculated reading, its square is equal. Here according to this A divided by B, doesn't matter. Division and multiplication both we have to put plus marks. Okay, so first term here A, delta A over A, here that instead of that A we can use the length L1, delta L1 divided by that length. That means here the A mean upper part, that means the length of 81 means our test cells distance. So this is our test cells length square plus delta L, instead of this delta L, 2 means the standard cells length, that is 53.6. The length is LS here and square, and we have to get the plus. Third part is this multiplication x, that is here multiplication x. Yes, so it should be the potential value. It means our working batteries voltage value. So that means P, delta P divided by P square. Okay, now this delta E value we have to calculate. That's the thing we have to find out. That's the error of this reading. Where reading එක error එක තමයි මේ delta E කියන්නේ. What is E? We have to find out delta E. What is E? E is our calculated value 1.8. Square is equal, what is delta T? Our test cell distance is 81.0. Here plus or minus 0.1. That means plus or minus 0.1 means here we know in potentiometer there is a meter rule. The minimum or least count කුඩාම මිනුම තමයි 0.1 centimeter. Least count is 0.1 centimeter in that meter rule in potentiometer. So that is the least count. Here delta T means the error of length. So this is least count of length 0.1. Error of least count is we have to divide 0.1 by 2 equals 0.05. So here delta LT is 0.05 divided by the length. Length is 81. Here centimeter square plus delta LS standard cells distance. However, it also 53.6 0 plus or minus 0.1. We know in meter ruler usually the least count කුඩාම මිනුම 0.1 centimeter. That's the least count. It is not the error. Least count එකයි error එකයි කියන්නේ දෙකක් ළමයි ඈ. මගේ පරණ වීඩියෝ එකක් තියෙනවා කියලා බලන්න. Least count එක කියන්නේ එකක්, error එක කියන්නේ එකක්. මෙතන මේ delta කියලා අපි දාන්නේ error එක හැම වෙලේම. Least count එක නෙමෙයි. So ඔයාලා දීලා තියෙන්නේ මොකද්ද? මේ දුරක් දිගක් වෙනලා least count එක දීලා තියෙනවා. කුඩාම මිනුම දීලා තියෙනවා. හැබැයි ඒක error එක නෙමෙයි. error එක හොයාගන්නේ කොහොමද? හැම වෙලේම පොදු සූත්‍රය තමයි least count එක කුඩාම මිනුම දෙකෙන් බෙදුවාම මේකට තමයි කියන්නේ error එක කියලා. ඉතින් ඒක 0.1 අපිට දෙකෙන් බෙදුවොත් එහෙනම් අපිට එන්නේ 0.05 again divided by එයාගේ length එක කීයද? 53.6යි. එයාගේ වර්ගය. ධන තුන්වෙනි එක එනවා. Potential of this working battery is 1.2. P is 1.2. What is delta P? Delta P කියන්නේ voltage එකේ error එක. එයාගේ error එක කීයද? ඇත්තටම මෙතන මේ 0.1 volt කියන එක දෙකෙන් බෙදන්නේ නැහැ. We don't divide it by 2 because in voltmeter it contain a digital screen. Digital screen එක value එකක් නම් එයාගේ තියෙන minimum least count එක තමයි එයාගේ error එක. The least count of and digital reading will be the error itself. We don't want to divide it by 2. තේරෙනවද? අපි දෙකෙන් බෙදන්නේ හැම වෙලේම අපි meter rule එකක් burette reading එකක් වගේ අපි between 2 points we manually measure that measurement and we can get that least count and we will divide it by 2. අපි දෙකෙන් බෙදනවා. හැබැයි digital readings we can't divide digital readings by 2 to calculate the error. So the least count of digital reading will be the error itself. Digital reading එක error එක කියන්නේ එයාගේ කුඩාම මිනිමුම තමයි. එතකොට මෙයාගේ digital display එකක් තියෙන voltmeter එකේ 0.1 තමයි අඩුම මිනිම. ඉතින් එයා තමයි අපිට දාන්න වෙන්නේ 0.1 volt කියලා. and square. මේක සුළු කරගන්න ඕනේ. කොහොමද සුළු කරගන්නේ? පටල ගන්න එපා. මේ තනි එක වෙන වෙනම සුළු කරගන්න. Use the scientific calculator and individually simplify this single term 0.05 divide 81 and get the square by using calculator. What is the answer? I will give you the answer. For this, I will erase. Here, delta E divided by E square is equal. For this value, I got 3.81 into 10 to the power minus 7 plus next one 8.7 into 10 to the power minus 7 plus 6.94 into 10 to the power minus 3. You can get the summation of these three terms and it will be 6.94 into 10 to the power minus 3 is equal delta E divided by E. E we know our calculated value 1.8 and they are square. So because of this square, we can get the square root to get rid of this square. Then square එක අයින් කරගන්න මෙයාගේ වර්ගමූලය දැම්මා. And we can get delta E is equal to square root of this 6.94 value multiplied by 1.8. Don't put square root to 1.8. Only this. Okay. The delta E value will be 0.15. So final reading. They asked in last question, in question number 7, state E up to the correct significant figures. Significant figures mean here there is a video in my playlist in general chemistry kits. What is that? Significant figures. Go through that and get an idea about that. I am not going to tell about significant figures. However, here the final value we have to express by using these rules of significant figures. So here 0.15. Okay, we can round off because this error, this is the standard error. Standard error should have only one figure. Here there are two figures, 1, 5. They have to convert into 1, so we round off and we will get 0.2. 0.2. According to this, we have to adjust our calculation part of our voltage. Initially the calculated voltage of our test cell 1.8 something, 1.810 something like here I didn't write that. However, in calculating you will get that value. And here according to this we should have only one point, decimal point, so we will get our point as 1 up to 1 decimal point because the error should have 1 decimal point or one figure. Error should have only one significant figure. So it have one significant figure. So when we round off to one significant figure, it have only one decimal point. එක දශම ස්ථානයයි න්යාවි. එයා වට එනකොට එතකොට අපේ රීඩින් එකක් එක දශම ස්ථානයකට තමයි කියන්නේ. So 1.8 එක දශම ස්ථානයයි plus or minus 0.2 volt. This is the last value. එතකොට මේ ප්‍රශ්නේ ඒක තමයි බලාපොරොත්තු වෙන්නේ. ඉතින් මම හිතන්නේ ගොඩක් දේවල් කවර් වුණා මේ ප්‍රශ්නේ. ඉලෙක්ට්‍රෝ කෙමිස්ට්‍රි වලට වුණ ගොඩක් දේවල්. එතකොට අනිත් ඉලෙක්ට්‍රෝ කෙමිස්ට්‍රි ප්‍රශ්නත් මේ වගේම තමයි එන්නේ. Theories are same. I think everything in every past papers, the general theories I explain in this video. So go through that. This is the way. Okay. So I'm really sorry about this time constraint because I don't have much time to explain you more past papers. However, after this video, I will upload one past paper which have answers. So I can't do a video for that past paper. However, I will add photograph of that past paper and I will add into the my Google Drive. The link for that paper I will upload it in this description of this video. And if you don't have past papers, that also may have in that particular description folder in my Google Drive. Please go through that and please share these videos with your friends and that paper also. Okay, thank you so much. Have a nice day.